Hello everyone, are we live? Let me know if you can hear me. Can you confirm if we are live? Okay, so all good here. So in today's session, what we'll be doing is some a kind of basic mini project on image classification. So the whole idea of today's session will be creating a mini project on image classification where uh, the image classification will be basically on MNIST. MNIST is a kind of a data set. And so the idea is given any handwritten digit, we will be able to tell what number is this. Hello, Harsh. So if I can see, just let me just share my screen so that we can discuss about the project. So we are going like this. So for example, if I have a image, let's suppose it's 9 written in this image, and given this image, a normal human can easily tell that this is a number 9. But let's see what if machine can tell whether this number is 9 or not. So the idea of the project will be, given this input image, we have to predict that this is 9, and given this image of 7, the computer has to predict that this is the number 7. Good evening. Hello, everyone. Right. So this will be our mini project for today's session, and this is known as image classification because we are eventually doing image. We are classifying the images, right? We are trying to classify images into some categories like numbers 1, 2, 3, 4 till 0. Right. So this will be our mini project. So for this project, basically what we will be going to use is an algorithm called kNN. So kNN is an algorithm, and the algorithm is basically known as k nearest neighbor. K nearest neighbor. So we'll be going to study about k nearest neighbor first. So we'll be doing this algorithm from the scratch. So we'll be looking at the theory part in internal mathematics, and then we'll be coding this algorithm from in NumPy. And using this algorithm, we will be able to do the project. Is data science only for CS batch? No, this is not the case. So anyone can do the data science. Okay. So I hope you guys know about any programming language, for example, C++, Java, and if you know Python, that is a plus point. But even if you just know any any programming language, if you know how loop work, how if else condition works, so that would be sufficient, right? But if you know Python, that is good. Like the just basic of Python. No, like everyone can do data science, right? So let's talk about so if you talk about data science and machine learning, machine learning is basically we have 3 different type of machine learning. So if we just say what are the different type of machine learning, one is you must have heard about this called supervised learning. This thing called supervised learning. And the second thing is called unsupervised. Unsupervised learning, and the last one is called reinforcement. Right? So reinforcement learning. So generally there are these popular type of machine learning. Right? So we'll be going to talk about supervised more in today's session, because the project that we have for today's session is totally depends on supervised learning. So the image classification or the handwritten digit classification is basically a supervised learning. So let's just understand what is supervised and unsupervised reinforcement in a very quick way. So so when do we call any project or any algorithm as supervised, when you both have, while the training of a model, while training of any machine learning model, if you have both the input data as well as and output data as well. So for example, if you are training a machine learning model that can actually classify, that can actually differentiate between, dog images of dog and cats. So if you train that model, that will be known as supervised learning. Why? Because let's suppose this is a machine learning model, and you just need to teach him that how to differentiate between cat and dog, which images look like cat, which images look like dog. So what you will do, you will give lot of images of dog, lot of images of cat, and then you will ask this model, you will just tell this model to learn something, some features, so that it can differentiate between cat and dog, right? Whereas in case of, what you are doing is you are giving input is basically the image, and you are also telling that this is a dog, this is a dog, this is a cat, this is a dog, these images are dog, these images are cat, right? In case of unsupervised learning, you just give the input, you don't give output. So there is no output, you just give only input data, and using that input data, the algorithm or the machine learning model has to find some pattern, find some common pattern or the interesting pattern in the data. So and there are a lot of example of unsupervised learning in these days, right? And if we talk about reinforcement learning is more into towards games. For example, if a model can play Super Mario itself, or maybe Pac-Man, or on a Flappy Bird. So that can be, you can say that is a reinforcement learning. But our case in today's session, we'll be talking about supervised learning, and we'll be doing the project called handwritten digit classification. Right? Handwritten digit classification. So I hope everyone know what is classification. Just a simple word. Classification is just a simple word that actually means classify, to classify. For example, if there is a dog and cat, that is known as classification. You're classifying between cat and dog, or maybe you are classifying between numbers. For example, from 0 to 1 to 3, 4 till 9. So these are known as classification, or to classify something, right? A simple general English term. Can machine learning be used to bypass captcha? Yeah, you can do anything with machine learning. Yeah, you can use. Yes, you can use machine learning to bypass captcha. So basically, it can automatically tell what number or what character the captcha has, and then maybe you can just put automatically, and you can bypass it. Right. We have, in today's session we have Nitish. This is basic. Yeah, I know this. This is basic. Maybe in today, like in the next 2-3 session, we'll be able to take more sophisticated algorithm, more complex algorithm, or maybe we can do some EDA, exploratory data analysis. But like starting from today, we are just taking the basic algorithm. kNN. Right. So if we talk about kNN is basic, one of the very basic algorithm. You can just treat it like a brute force. So what actually happened in kNN? So one point is kNN can be used for classification or the regression. For example, if you want to predict the price of a house, or if you want to predict, let's say, stock prices, or the marks of, or maybe air quality index, you can also use kNN for these type of examples. And kNN can also be used for classification, like handwritten digit classification, or dog versus cat classification. You can use kNN for these type of tasks as well. So it's a very simple approach, or you can say naive approach, brute force approach. So what actually happens is, let's suppose you have two features. Let's say there is a size, and or let's say there is a height of animal, and there is a weight of an animal. There are two features, right? So the data set looks something like this. You have height, and you have, let's say, weight. right? So let's say there are two different type of animal. One is your cat and one is your dog, right? So you have to this is your target variable. Target is basically what you have to predict. We are just taking an example. So if the height is small, for example, if height is 1 meter and the weight is also, let's say, 1.5 kg, it's a cat, let's just say. And for example, if height is, let's suppose, uh, maybe 2 meter, or and the weight is also large, for example, 2.5 or let's say 3.5, then this is a dog. And let's suppose if the height is 0.8 and the weight is 1.2, again this is a cat. So let's suppose you have a lot of examples of cat and dogs. For example, you have 100 such examples, right? And now if you try to scatter on this plot, this graph, it will look something like this. So let's say these are your cats, because they have small height and low weight, so they will lie somewhere here, right? Whereas if you talk about dogs has a large height and they have also large weight. So let's say they are lying somewhere here. So these are dog data point and these are cat data points, right? So for example, now if you have to predict something, let's suppose there's a new animal. There's a new animal, and this animal has a weight of, let's say there is a height 5 meter, and the weight is, let's say, 3 kg. Now this animal will lie somewhere here. So height is very high and weight is also very high. Change the color to blue. Just a second. Okay, so that animal will lie somewhere here, right? That animal will lie somewhere here. And now what you can do, you can easily say that this animal is more of a dog, right? Because cats, these are cats and these are dogs, so you can easily say that this is a dog, right? So so this algorithm is actually basically known as kNN. So what you are doing is you are taking few of the nearest animals, and then you can say what is the majority vote. So let's just take the example, right? So the algorithm is something like this. So if you want to write the algorithm, I guess blue is not visible on this. Maybe we can change the color. So the algorithm would be, the first step is this is your point, right? This is actually known as your query point. Why query? Because you want to ask for this point. You want to ask prediction. You want to take the prediction for this point or this data. So basically, what you do is you find the distance. You find the distance of this query point with all other points. You find the distance of query point with all the other points, right? Whole, like you have 100 examples, so you will find the distance of this query point with other 100 points. And the second step would be you will sort them in ascending order. Yeah, you can sort them in ascending or descending, whatever you want. You have to basically sort them. So let's say in ascending order. In ascending order. Now what you will do after sorting, you will, let's suppose here basically in kNN, this k is basically your number. For example, you can put k value as 5. So it will become 5 nearest neighbor. You can put k value as 7. It will become 7 nearest neighbor. You can put k value as, let's say, 9. It will become 9 nearest neighbor. So let's suppose if k value is 5, it will become 5 nearest neighbor, right? So you have to take the 5 nearest neighbor. So take the take k nearest neighbor, right? Take k nearest neighbors. You have to take the k nearest neighbors. And so let's suppose if you take the 5 nearest neighbor to this point, let's say this is the first nearest neighbor, this second, this third, this fourth, this 5, and then do the majority vote. Do the majority voting. So in our case right now, all the 5 nearest neighbor are the dog, right? That's why we can say that this point will be a dog. But for example, if your data point, if your query point will lie somewhere here, then in that case, this will be your first nearest neighbor, this will be a second nearest neighbor, this will be a third nearest neighbor, this will be a fourth nearest neighbor, this will be a fifth nearest neighbor. So you can see these are your 5 nearest neighbor. But in this case, there are 3 cats, right? There are 3 cats and there are 2 dogs. So what you will do? You will take the majority vote. So majority says that this data point, that the query point is actually the cat. So that's how we can do the prediction for new data points, right? So this is the algorithm that we are going to implement, and let's just first implement this algorithm on a very basic data set, and then later we can try to implement this on the MNIST data set so that we can do a project as well, right? So right now we'll just implement on a very dummy data set. But I hope the idea of the whole algorithm is clear. So let's just, if you want to quickly revise the algorithm, so kNN is basically k nearest neighbor, where k is any number, like you can put 5, 7, 9. Generally, we put odd number. That's why we put odd number. In case of a tie, we will never have a tie if you put odd number. But if you put 6, you may have tie, right? That's why always put an odd number. So after putting the odd number, so what you have to do, you have this data set. For example, you have the class 1, which is these are cats, and the above one are dogs. You have a new query point. Let's suppose this is a new animal. You want to ask the prediction for this, right? What you will do, you will take the distance of this query point with all other points. So first step is take the distance of query point with all the other points. The second step is sort all the distances in ascending order, and take the third step is take the k nearest neighbor. So if the k value is 5, take the 5 nearest neighbors. If k value is 7, take 7 nearest neighbor, right? And the last step would be take the majority vote. And simply this is your prediction. Majority vote will be your prediction. So this will be your prediction, right? If you do not understand क्या चल रहा है या फिर कहाँ से start करना है, so maybe you can just start with basic Python, and then you can see this, watch this session later, because this will be available on YouTube, so you don't have to worry about it. Just start with basic Python first, basic Python or NumPy or Pandas. So just learn Python, basic Python, and NumPy and Pandas. So these are the 3 things you can do if you do not understand anything, right? So let's move forward and let's try to code this algorithm in our. So for coding, basically, what I prefer to keep, I prefer to use the Google Colab, so that if others also wants to do the code, they can also do. So let's open the Google Colab. So just simply write Google Colab. Simply write Google Colab, and the first link that appears is basically the Google Colab. Colab is basically a Jupyter notebook, kind of a Jupyter notebook that runs on Google server. And you will see it is now right now connecting. So connecting actually means it is allocating some resources to you. So let's just let it connect for a second. It will initialize and then it will be connected. So once you see that it is connected. Now you can work on this. So I'll just remove this line for now. You don't have to write this line, so it's not required. So we'll come to this later when you need to get the data set, but not right now. So you can give any name if you want. Right now, it would by default it would be untitled. Let's just start with a basic kNN. So let's import some libraries also. Let's import NumPy. So NumPy is basically library for scientific computation. For example, if you want to work with matrices or vectors, or if you want to take product between two numbers, so you can use this library called NumPy. What is MNIST? So MNIST is basically an organization, you can say, that has some data set. So basically MNIST data set is very popular data set that has a lot of digits. For example, it is basically like images. It will have images like 6, it will have images like 9, it will have images like 0. So from 0 to 9, it will have images, lot of images, like around 40,000-50,000 images. And then using those images, we can train our model so that we can predict in the future what the number is. So MNIST is basically a kind of a data set. And let's also import a library called matplotlib so that we can visualize our data or visualize our numbers. So let's import matplotlib.pyplot as PLP. So before writing the algorithm for kNN, what would you need? You need a data set, right? Data set, something like, maybe you can take a dummy data set for right now, because we will just talk about cat and dog data set. And that was also a dummy data set, not an actual data set. We'll talk about actual data set in just a bit when we talk about MNIST and then 100-digit classifications. But let's just, for right now, let's pick a dummy data set from scikit-learn, another library, and let's do the kNN classification on a dummy data set first. So for a dummy data set, what you can do, you can create a own data set, but right now I'm just taking the help of a library. Yeah, import data set, right? Okay. So I can use a library called sklearn. So I can write from sklearn.datasets import. There's a function called make blob. This is the function, right? So we can use this function to create a dummy data set. So this will return basically two things. One is called X and the second one is called Y. What is X? X is basically your input data. For example, your data of height and weight. And Y, what is Y? Y is your labels. For example, if the cat, if this is, if any cat has low height or very less weight, and it will have basically Y as cat. But in machine learning, we do not have cat and dog, but rather we will have a number. So that number will be maybe 0 or 1. It could be anything. So we'll see this thing. Let's just create a data set first. So let's call this function make blob. And it receives few parameters. So first parameter is called nsample. So what would be the nsample? It is basically the number of data points. If you want number of data points as 100, you just keep nsample as 100. Simple. If you want some other, like if you want 200 or 500, you can change that. And the second parameter is n features. Again, it would be 2 because we want only 2 features. One is basically like your height, and the second one is your weight. So we want 2 features, right? And the third parameter is basically it's called centers. And what centers actually means is how many classes do you have? Like how many animals do you have in our case, if we talk about cat and dog. So if you have 3 animals like cat, dog, horse, then you would put 3. But right now we just have cat and dog. So let's just put 2 only, right? And other parameter we can skip, but let's just focus on this parameter called random state. So okay, so let's not okay, so you can put random state. You can put any random state. So random state is basically, it will give the same data again and again. right? So just do shift enter to execute it. And now if you see X, what is X? X is something like this. Now you can see it has 100 rows that actually corresponds to 100 data point. And there are two features, right? One feature, two feature. So maybe this feature is your height and this is your weight. Right? So we have two features and 100 data points. Similar to this, we have Y also. Y actually means your labels. If you just print Y, what are your labels? So labels will be like 0, 1, 0, 1, 0, 1. So actually 0 means a cat and 1 means a dog or something like that. Or 1 actually means your cat. So we'll figure out which one is cat and which one is dog. So, but before that, let's just visualize this data in the format of graph. For example, we just we looked at this graph, right? This is your cats. These are your cats, and these are your dogs, right? Let's visualize in this format. So to visualize this in this format, what we can do, plt dot scatter. This is a graph, or this is a function called plt dot scatter. So where does this plt come from? This is from matplotlib, right? And then on the x-axis, we can plot all the first column of x data, because that's we have height. On the y-axis, we can plot all the rows of the, you can say the second column, right? So we will write x all this means all rows and the second column. This means x basically the data, all rows. This colon means all rows, and 0 means the first column, right? And if you want to give a color, let's say white. It's totally optional. If you do not want to give a color, that would be fine. Now you can see it look like cat and dog data set. Now you can ask that how the height can be negative or the weight can be negative, but let's not focus on that thing, because you can say it is normalized data, and normalization is very important in a data set. But let's say this is a dummy data set, and dummy data set can be negative. We do not focus on height and weight, but let's just say these are some quantity or some features or some numbers, right? But these are your dogs, or no, these are your cats, and these are your dogs, right? And let's suppose there's a new point, a new animal somewhere here. Now you have to find the prediction for this. You have to find a prediction for this. So how would you do that? Again, you will apply kNN algorithm, and to apply kNN algorithm, you obviously have to write it first, right? So we will write the kNN algorithm. So all the 4 steps that we have written in our pseudo code. So we will be writing kNN algorithms from scratch now. I hope you have got the idea what we are trying to do, and then we will apply the same algorithm. This whole the algorithm will remain same, just the data set will be different. We'll be applying on the handwritten digits, right? So let's make a query point first. Let's write a query point, and let's say this point is somewhere here. Somewhere this point is somewhere here. So let's say x-axis is 0 and the y-axis is around minus, let's say minus 5. Minus 5 would be fine, right? Let's say minus 5. So x-axis is 0 and the y-axis is minus 5. So now if you want to see where this point actually lies, so what you can do, you can again copy this, and in addition to the scattering, you just have to scatter this point as well, query point. Query point of 0 and query point of 1. Deep learning, maybe like in next few sessions, like maybe next in 2-3 sessions, we will be covering some deep learning projects as well. So definitely, we'll be doing exploratory data analysis and other part as well. So this is the animal that you have to find, whether this is a dog or cat, right? So how do we know that zero represent what, cat or dog? So basically, what we can do is we can look at the first data point. So first data point has a height of 0.18, somewhere here. 0.18 will come here, x, and the y is -9. So -9 is around this, right? So 0.18 is this, and -9 is this one, this, right? So basically, so the first point is representing cat. Now let's see what label it got. So it has a label of 0 or 1. Let's just see. So it has a label of 0. It means all the cats has label 0, and all dogs will have label as 1. So all dog will have label as 1. All cat will have label as 0. Right. So now let's write the kNN algorithm somewhere. So let's start writing the kNN algorithm. So since we wanted to find the distance, right? We wanted to find the distance between query point and all the other points. So what we would be needing is a function to find the distance between 2 points. Right? So first we will be writing, and this distance will be Euclidean distance, a normal Euclidean distance. Everyone knows what is the formula for Euclidean distance. So it's x1, or let's say 0.1 minus 0.2. So if you're writing with in case of 2 dimension, it would be x1 minus x2, or x2 minus x1 plus y2 minus y1. But if you have 3 dimension as well, what you will do, you will write z2, or maybe z1 minus z2, anything you can write, z2 minus z1, so on, right? So we can write this function as define distance, and there will be 2 points, p1 and p2. So what we'll do, we can simply do p2 minus p1, and then we will do the squaring, right? We will do the squaring. So squaring we can do this way. Double star 2 means the square raised to the power 2. And after this, we have to do sum. So we'll use a function called np.sum. So we have done the sum. So it will take the sum of this part, sum of this part, sum of this part. And after taking the sum, you have to take the square root. So how can we take the square root? It's simple. For taking the square root, you can do double star 0.5. Because double star 2 is square. So 0.5 would be under root, right? So this is the basic function to calculate distance between 2 points. So if you want to calculate distance between something like this, if there's a point 0, 0, and if there's a point 5, 0, or let's take 2, 2, right? So what would the distance? You can simply say distance np.array. Let's try to check distance between these 2 points. One is 0, 0, and the other one is 2, 2, right? So let's see what is the distance between these 2 points. Okay, so you need to return as well. So from here, you need to return as well. So we haven't returned, so that's why it's not giving any answer. So let's return now, and it's giving 2.82. So I hope this would be the answer between distance between 2 points. Right? So it means we have written our functions correct. Now let's write the function for kNN. So we will write define kNN. It will receive the data x, which is your which is the input data, and it will receive y. It will also receive the query point, and it will receive the value of k. So let's keep the value of k as 5 by default, right? So this is called default parameter. So let's keep k as 5. Now let's check how many data points are there. So to check the data points, we can simply do x dot shape of 0. It will give 100. Basically, what x dot shape gives? X dot shape. It gives number of rows and number of columns. So basically, number of rows are 100 and number of columns are 2. But if you want to take the number of rows only, you will write x dot shape of 0. So what this x dot shape of 0 gives? It will give 100. Right? And after this, let's write a list called all distances, and it will be empty list. Now you can iterate over all the numbers. So how many numbers are there? How many data points are there? We have m number of data points because we have taken 100, right? So m. And what you will do now? You will take the distance of the query point with each point, with each you can say each data point. So let's say d is equal to, you will call this function distance function, right? So let's call distance, and let's say first point is your query point because you want to calculate the distance of query point from xi. Why this xi? Because you want to calculate the distance of query point with each point. So I is basically the iteration. In the first iteration, it will pick the first point from the data set. The second iteration will pick the second data point, right? So it will calculate the distance and give you the distance d. Now what you can do, you can just simply append all distances dot append. You can simply append d, and like it will append all the distances to this list. And after this, after completing this loop, what you can do, you can just sort the list, because the second step was to sort, right? All distances is equal to sorted. So this is the function, inbuilt function in Python. So you can use it, this function in any list, and it will give you the sorted list. So just write sorted and all distances. Is there any library for the same library for what? For kNN? And let's take the first k points. Let's take the first k points. So k is basically 5. So let's take the first k points, right? And for right now, let's only let's return this all distances list. What is this all distances? For right now, but we'll change. We'll change this later. Let's just see. Now let's try to call this function kNN. Let's pass the whole data because it received the input data x, and it also received the y. So let's also give the y. Let's also give the query point that we have already defined. Where is the query point? We have this query point. Yeah, so we have the library for kNN. So that is in scikit-learn. So we have scikit-learn, and scikit-learn has a lot of functions for all models. So yes, we can use scikit-learn, but if we implement from scratch from our own, we'll be able to get more insights of what's actually happening inside the algorithm. Let's pass the query point. And you can skip the k value because it's by default 5. So yeah, you can skip. If you call this function now, you will receive the 5 nearest neighbors. So these are your 5 nearest neighbors, but they are only the points. No, they are only the distances. They are not telling whether this is cat or dog, which what are the 5 these points actually means, or what classes do they have. It is not telling, right? So we do not care about the distances. Rather, we care about what are the 5 nearest neighbor and what is their label. If we get the label, that will be our whole motive. right? So label is stored in while, right? So while you append the distance, what you can do, you can also append their labels. So if you append their labels, then you can simply convert all distances to the numpy array of all distances. And now if you do, maybe like you can do it later over here. Now if you just take this, you can see now along with the distances you're also getting the labels. So this is the first point, that is the nearest, and it has a label of 1 means it is a dog. Again, this is a dog, but this is a cat. So there are two cats, and there are three there are three dogs, right? So we can now take the majority. So how do we take the majority? So let's try to write a function, or maybe let's try to write a simple code. So we do not care about distances anymore. We do not want distances. We just simply want what are the labels. So I just want labels. So labels would be all distances of all rows, and I can say take labels. So now you will just have labels. You just need to find how many labels are there and which label is there. So what you can do is you can find a function. There is a function called unique, np.unique, and you can give this labels. And it has a parameter called return counts, because it will first tell that how many unique numbers are there. So it will tell there are two unique numbers, 0 and 1. Now this return count also tell how many times the 0 is appearing. So it will say 2. How many times this 1 is appearing? It will say it is appearing 3 times. So that's what we use return count for. So I want to have this counts as well. So I will write return counts as true. Now it will give two things. One is your basically you can say labels. These are your labels, right? These are your new labels, I can say, or new labels. Let's say new labels. And the second one is called values. Right? Now I just want to get what is the maximum index in the value. So I will use a function called np.argmax of the values, and I will take the new label of this, and this will be the prediction. This will be the prediction, and I'll just write prediction. I'll return the prediction. If you run this, it will say 1.0 is the prediction, because for this data point, for this query point, remember this query point, what is the prediction this is giving? This is giving dog, right? If we change our data point, for example, my data point now looks something like, let's say -8, something like this. Now my data point is over here. Can you see this blue point, small blue point? Now this is my query point. I want to ask the prediction for it. Obviously this is cat, right? And cat is basically 0. What label does cat have? 0. So hopefully our kNN model should predict that this is also 0. Now let's run our kNN model. So you just need to simply call this function kNN xy and pass the query point. And now let's see if it gives or returns 0 or not. So yes, it is returning 0. So if it is returning 0, it means it is saying that this new data point or a query point is your cat, right? So this is how simple we can write kNN algorithm for very basic example of cat and dog classifier. But this is not very interesting, right? Let's do for handwritten digit classification. That would be more interesting. So let's quickly take the data set. So let's write handwritten digit classification. So I'll give you this link. So I'll give you this link on chat box. So if you want to get the data set, you can take this data set from here. So I'm taking this data set from here. Yeah. So just copy this link. So I have already copied. Now what you need to do is you need to get this data set on your Google Colab. So I'll use a command called wget. So wget is a Linux command that can actually get the data from the internet. So I will write wget and pass this link. And also you need to put a exclamatory mark before this, because wget is not a Python command. Only you can only run Python command in this Jupyter Notebook or the Google Colab. But if you want to run any Linux command, what you have to do is exclamatory mark, right? Now if you just click over here, let's just delete it right now. We do not have this train.csv. Again, we will generate it again, right? So let's do shift enter and we will get the data set. Now you can see we have got the data set. So this is our data set train.csv. Although you can rename it, it's not required to have a name called train.csv. Maybe we can rename it to MNIST. Let's rename it to MNIST.csv, right? MNIST would be more suitable name. Now to read this CSV file, we need a library called pandas. Let's import pandas as PD, and we can read this file as pd.read_csv, and you just need to give the file name. So file name is mnist.csv. So we will get the file in the format of data frame. You will see this. So let's write it in the data. So now we have got the data, and let's see what is the shape of data. If you just check the shape of data, what this shape actually tells. So it means there are 20,000 images, and each image has 784 features. And now let's see what are the 784 features. So if we do data.head, it will actually tell you that okay, so right now all are zeros. Maybe we can check more numbers. Yeah. So basically these all are features, or these are our pixels. So each image is basically like something like this: 28 cross 28. So each image is 28 cross 28, and it's black and white image. So what they have done is they have taken this image. For example, let's suppose there is 6 written over here, right? They have taken this image, they have flattened it. For example, from here to here, they have put it like this. And from the second row, they have picked the second row pixels, and then they have put it something like this. And the third row, and they have put it something like this. So they have done for all the 28 rows something like this. And this is how they have created one row. And this one row actually means one image, because one row will have 784 pixels, right? Because 28 into 28, how much? 784, right? 784. So if you see 784 pixels, it actually means that if you convert into square format, something like this, if you reshape it into square format, it will become an image, for example, 7 or 0 or 1. So why does it show 785? Because the last column last column is actually your label. For example, this image, the first row corresponds to number 0. The second row corresponds to number 3. The third row corresponds to number 6. And we can also verify it. For example, how we can do this? If we just let's write MNIST is equal to data.values. So let's convert into X and Y, right? Let's take X. X would be MNIST. All rows, all the columns except the last one, because last one is your label. So label always go on Y. So label, MNIST, all rows, just the last column. So now you have X and Y, and we will visualize it. We'll visualize the data. So if you just see X of 0, what is X of 0? It look like something like this, right? But if you reshape it, in 28, 28, it will become a square. Right now it is just a flattened vector of 784 pixels or 784 numbers. But if you reshape it into 28, 28, it will look like an image. But again, it is looking like numbers only. How it is looking like a image? If you just write plt dot IMShow and just pass this thing, it will look like an image now, as you can see. And the number is 0, right? And if you change the image, for example, if you want to change the image, second image, just write X of 1. It will give the second image. And let's see now. So it is 3, right? And if you check the last column, it was saying that second image was 3, right? Even you can also verify. Just write what is Y of 1. It will say 3 because Y always contains the label, right? Y contains the label. If you want to check any random image, for example, 789. Let's see what is 789 image means. So it is 7. And if you check what is Y of 789, it is also 7, right? So this is how we have the data set. But what we can do, we can split the data set into 2 parts. So we have 20,000 images. Right? What we can do, we can use 15,000 images for the training part, and we can use 5,000 images for the testing purpose, so that we can report the accuracy, how much accurate our model is. For let's suppose we have 5,000 images for the test. So out of 5,000 images, how many times our model is able to correctly classify or correctly predict, right? डेटा सेट एक बार और बताना है डेटा सेट, और या फिर यू वांट टू चेक द लिंक? अच्छा, कैसे? अभी करा नहीं है, स्प्लिट नहीं करा, अभी हमने स्प्लिट नहीं करा, बट नाउ वी आर गोइंग टू स्प्लिट द डेटा. सो लेट्स राइट द कोड टू स्प्लिट द डेटा. ठीक है, अभी किया नहीं है, अब करेंगे. अब यहाँ पर करते हैं ट्रेन टेस्ट स्प्लिट. So हम क्या करेंगे? We will take the first 15,000 images out of 20,000 images for the training purpose. So we have, just remember, we have X, we have Y. What is X? X के अंदर we have images, Y के अंदर we have labels. ठीक है? तो अभी हमें X से हमें X train बनाना है, X underscore train. So ये कैसे बनाएंगे? We will take the first 15,000 images. We will write X starting from 0 to 15,000. ये X train आएगा. अब जब X train आया तो हमें Y train भी चाहिए. So it will also, let's write Y underscore train. You will write Y from 0 colon 15,000. It means 15,000 images X train में आ जाएंगी और first 15,000 label Y train में जाएंगी. Similarly, you will do for X test. But X test 0 से start नहीं होगा. It will start from 15,000 and it will go till 20,000, right? Similarly, Y test, it will start from 15,000, it will go till 20,000, right? And this way we will have a fair split, like 15,000 for the training purpose and 5,000 for the testing purpose, and that is fine. If you want to check how many images are there in the train and the test, you can simply check xtrain dot shape. So ये ट्रेनिंग का बता देगा कितना इमेजेस है, 15,000 as you can see. और अगर आप x टेस्ट का चेक करना चाहते हो तो again it will tell that there are 5,000 images. 4,919 because there is one image less. Right? Now let's try to implement. Let's try to implement this kNN algorithm that we have already written on this data. So let's say, see, देखो training के लिए we will only use xtrain and ytrain. Training के लिए we will only use xtrain and ytrain. We won't use xtest for the training. ठीक है? xtest किस लिए? To get the prediction. Prediction के लिए. तो xtest में से ना कोई एक random image उठा लेते हैं. So let's say xtest में कोई भी एक random image. Let's suppose 67. ठीक है? ये हमने एक रैंडम इमेज उठा ली. अब हम इसके लिए प्रिडिक्शन करेंगे. ये तो बहुत सारे नंबर्स दिख रहे हैं. वी डू नॉट नो व्हाट दिस इमेज इज, बट इसको कैसे प्लॉट करके देखेंगे. सबसे पहले इसको रीशेप करना है 28,28 में. क्यों करना है? बिकॉज अभी तो ये सिर्फ एक वेक्टर है 784 का. 784 नंबर्स का वेक्टर है. इसको रीशेप कर दोगे 28,28 में, देन इट विल बिकम अ इमेज. ठीक है? और इमेज प्लॉट करने के लिए just write plt.im show. So this has number 4, right? 75% discount on website. Maybe you can ask the support team to get your discount on the courses. I do not know about the discount courses. Just shoot a mail to support@coding. I'll check that. Okay, but I do not know about if there is any campaign going on. But let's just leave that. Maybe you can ask the support team, right? So this image is 4. Now let's see what our model actually predicts. So for our model to predict, what we will do? We will call the kNN, right? We will call the kNN. We will pass xtrain, we will pass ytrain, we will pass the query point. Now what is query point? Query point will be xtest of 67. This will be the query point. Let's pass this, right? And let's see what the prediction this model gives. Let's see what prediction our kNN model gives. Okay. So as you can see, our model has predicted number 4, right? If you want to convert it integer, you can easily do. Let's convert it into integer. Okay, do it. You can see, right? So you have got prediction as 4. Now let's check for other images as well. So let's check for, let's say, 99. So the number 99 image is 2. It looked like 2, right? Let's see what our kNN model actually predicts. Our model is predicting 2. So that is a good model because it is able to predict a lot of numbers. So if you just you can simply loop. You can simply do a loop. For example, you have 5,000 images in the tests data set, right? So what you can do, you can just loop over 5,000 times, and let's predict for all the 5,000 images, and you have y-test. Remember, you have y-test. What is y-test? In the y-test, you will have the label of actual test images. For example, if you check y-test of 99, y-test of 99, x-test of 99 was this image, but y-test of 99 will have 2. Why? Because y always contain the label, and now you can see 2. And our model also predicted 2. So now you can see both are matching. So out of 5,000 times, let's say your model actually predicts 4,000 correct, right? So what you can see, what is the accuracy? 4 by 5, or it will be random function can we use? Yeah, you can use a random function. So let's generate any random index between 0 to 5000, and then let's see what prediction it gives, right? So for the random function, what you can do, simply let's write any index np dot random int from 0 to 5000, right? We just want one number. So index can be anything. There's a what happened? I have not. Acha, it is rand int. The function name is rand int, not the random int. It's rand int. So you will get the index. Index can be anything, like from 0 to 5000, it can be any index. Now, instead of 99, let's write index. And let's see what number it says. It looks like a 8, right? And instead of 99 over here, again, let's write index. And let's see what our model actually predicts. Our model is predicting 1 this time, as you can see. As you can see, our model is predicting, yep, it should be 499 only. 4999. Oh, 4. So this time our model is predicting wrong. So it can happen, right? Because it is not perfect, 100% perfect model, but maybe like once in a 10 time or once in a 20 times, it can predict wrong as well. So it's not a perfect model. It will not give 100% correct result, but most of the time, if it get these results, these images, how would we expect a simple model to predict correct? Right? Again, you can see it is predicting wrong. But let's try one more time. Let's generate one more index and let's see. So maybe it looked like 7, right? And let's see what our model predicts. So our model has predicted 7. So this time our model has predicted correct answer. So maybe you can run this for around 50 or 100 times or 500 times or even 5000 times and then see. So I guess the accuracy would be around 95%. It means it will be able to predict 95% time correct. So in 100 times, it will only predict 5 wrong. So I hope you are able to understand what is kNN, how we can write the kNN algorithm, and how we can also implement it in a handwritten digit classification project. So I hope you got to learn new things. So I put the link of this notebook on the once the session has ended, I'll put the link on the comment box. So or the description. So I'll put on comment or description. So if you want to get this notebook, if you want to take code, you can also run using this notebook. Right? So let me know if you have any doubt. Otherwise, we'll end the session. If anyone has any doubt, you guys can put your doubt on chat. Discuss about Data Science Master Live online course. What do you want to discuss about that? You want to discuss the course curriculum or the topics? I know the concept very well, but coding करने में problem होता है क्या करूँ? So if you stuck in coding, the only solution is code more. So this can happen that if you are starting with the coding, you might get a lot of doubts. But the only idea is if you solve your doubts and also others' code, then you will be able to quickly understand the code. And just pick any random algorithm. Just maybe how to take a square root of 2 numbers, or maybe how to sort any list. So just pick any random algorithm and try to code that in Python or any language if you. Regarding the content, if you want to check the content, you can check on the website. So for the live course content, we are actually updating the content right now. So maybe in next 2-3 days, you will get the actual content. So we'll be discussing, we'll be introducing object detection and I guess attention modules and other stuff like how to do Kaggle in the live data science course. So I think this time live data science course will have a lot of other topics that are not on the online course. And for the online course, you can always check this website called online.codingblocks.com. So it will have the whole curriculum, right? You can check that. Yeah, if you're a CS student, that is perfectly fine. Like CS non-student, that actually doesn't matter. But if you do code for 3 months or 2 months on a regular basis, you will be able to obviously able to do very good. In fact, you will improve yourself over time, right? So there's no need to be hard on yourself. So maybe if you are in the starting, if you are stuck somewhere, if you having some doubts or if you get errors, that is natural. Everyone gets errors. Should I use the website above mentioned? Yeah, you can use the websites. Yeah. So I think thank you very much for attending the session, and this video will be available on the YouTube channel. So if you want to share with others, or you want to watch this session again, and you want to do the same project, may so kNN is very good algorithm that you can even build a Pokemon classifier or Pokemon detector. Something like if there is a Pikachu, I cannot draw Pikachu, but if there is a Pikachu or Charmander or Bulbasaur, you can even differentiate between these images. Not only just 6 or 7; these are like basic examples, but you can do these real life examples. You can differentiate between Pikachu, Charmander, Bulbasaur, other Pokemons, right? So yes, you by using kNN. Okay, so MLK algorithms. So I don't really understand that these algorithms are very slightly hard to understand at the first, and obviously to implement they are even harder. So if you do the linear regression two three times, then you obviously would be able to understand that, right? So I would just say that you have to do a lot of practice. A sports analyst, uh, something about sports analyst. So sports analyst, if we not talk about sports analyst as a general data analyst, that sports analyst is also kind of a data analyst also, right? Because but it just they work on the sports data, for example, uh, analyzing soccer data or football data or cricket data or IPL data. So if you have data, that it will depend on the whole data, how much data do you have, or in which format you have the data. But it is important to have the data first, and then we will be, because depending on the data you have to change your strategies. So if you want to check some data, maybe you can check on Kaggle, and it will have some data regarding sports or other categories. So regarding science and medical. Fan type companies, generally they prefer masters or PhD candidate, but they also take entry level data scientist or data analyst. But before that, you need to have a very good portfolio, and you should have some blogs written, or even if you have a research paper, that would be plus point. But definitely you should have good projects, and you should have blogs written over them. So yeah, portfolio is very important. If you have the portfolio, then you are good to go. But portfolio is very important. Like if you should have 4 or 5 good projects, like from data gathering to the productionization, like deploying that model in some any web servers, right? So these type of projects you should have end to end project, like the building a whole product, right? So I hope you will be able to create our other projects and portfolio, and you will be able to write blog on that. And obviously, you should have the fundamentals very clear. So fundamentals are very, very important. So you should have. So I think we can end the session now. Thank you very much. If you have any other doubt, you can post on the comments. So I'll be checking the comments later, and we'll be posting this notebook on the comments as well. So thank you very much for attending once again. Bye.